Hello everyone, I hope everything's going well. So before we talk about our idea and approach, let me first start this presentation with Elon Musk's quote. He said, "You shouldn't do things differently just because they are different. They need to be better." That's why we came up with our project idea Carzella. Carzella is a software solution for a safe autonomous vehicle that navigates in urban residentials. In general, there are two ways to implement a self-driving car, either end-to-end approach or modular approach. In end-to-end approach, we take the raw sensor data and output the commands for the car, as if the network in the model is a black box. In modular approach, we break the problem into modules and try to solve each module independently. For the sake of safety and for the sake of well understanding of the flow and the ability to debug the system in case of any failure, we chose modular approach. And here is our system architecture. The first module is perception, which takes in the sensor readings to perform detection, classification, segmentation, and calculating the distance between our ego vehicle and other agents. We use YOLO, UNet, ResNet for those tasks. The second module is localization, which takes in these sensor readings and output the location of the car using EKF, or Extended Kalman Filter. The third module is planning, which takes the output from the previous two modules and performs both long-term and short-term planning using A-star and model-based path planning respectively. The fourth and final module is control, which takes in the next state the car shall be in and generates the corresponding throttle, steer, and brake values, and we use PID controller in that module. So let us show you now a quick demo of a scenario that is supported and handled by our software. The upper half of the screen shows a bird's eye view of the environment. The red spirals are the candidate path to choose an optimal path from. The yellow dots are the location of the car. The bottom left is a visualization of radar and LiDAR sensor readings. The bottom right is a visualization of the detection and segmentation. So we can see now that the software is able to detect the front car. Based on this detection, it generates the spiral and it will choose the optimal path that avoids this collision. Here is a segmentation of the road now. After the car has successfully located itself and detected that the road is collision free, it's able now to get back to its lane. The car now tries to follow the center of the lane again. While getting back to the lane, it's able also to detect any pedestrians walking. Now we can see that it also detects the front car. And it's doing pretty well following the center line of the lane. Here is also a segmentation of the road and the readings of the radar sensor. It's worth noting that the client selects the start and end points of the car, and the end point shall be here. So the car shall be able to decelerate to stop and apply the brakes till that point. So this demo was just a glimpse that shows one possible scenario of many scenarios that our software can handle in urban driving. Thank you so much.